Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra, chapter linear transformations, lecture number 1, in which I will show the practical approach to linear transformation. Firstly, I would like to clarify you that what is a linear transformation. Let V and V prime be two vector spaces and T be a mapping such that X, Y belong to vector space V domain and alpha beta belongs to F, a field. Then T alpha X plus beta Y equal to alpha Tx plus beta Ty. Then T is called a linear transformation. Now we write the definition. Linear transformation. Let V and V prime be two vector spaces over the field F. Let T be a mapping defined on V into V prime such that T alpha X plus beta Y equal to alpha Tx plus beta Ty for all capital X, capital Y belong to V and for all alpha beta belongs to field F. Then T is called a linear transformation. Now I will show the practical approach to linear transformation in which a square matrix plays the active role in place of T. Now I will show the practical approach to linear transformation. Let we have two set of frame of references in Cartesian system of coordinates. Let we call them by X system and X prime system respectively. Let this is X system in two-dimensional plane, and this is X prime system in the same plane. Let P be a point having coordinates x, y in X system and coordinates x prime, y prime in X prime system. Let P be a point whose coordinates in X system and X bar system be x, y and x prime, y prime respectively. Let us draw perpendicular from point P to X axis, and also we draw perpendicular from P to X bar axis. Let us draw perpendiculars from P to X axis and X prime axis respectively. Let this perpendicular is PA and this perpendicular is PB. Let us draw perpendicular from A to X prime axis and also draw perpendicular from A to extension of PB. This is perpendicular, this is perpendicular. Let this angle is theta. These perpendiculars are PA and PB respectively. Also, we draw perpendiculars from A to X prime axis and extension of PB. Let this is C and this is D. Since ACBD is a rectangle, therefore DB equal to AC and BC equal to AD. Let this is number 1, this is number 2. Since this is P, since PA be perpendicular on X axis, therefore OA equal to X and PA equal to Y. Also, PB be the perpendicular on X prime axis, therefore OB equal to X prime and PB be the Y prime. OA equal to X, PA equal to Y, OB equal to X prime and PB be the y prime. Let angle between x axis and x prime axis is theta. Therefore, angle between the perpendicular lines on them will be theta. Therefore, angle APB equal to theta. APB equal to theta. This will be theta. PA be the perpendicular to x-axis and PB be the perpendicular to x prime axis, and angle between them be theta. Now OB equal to OD plus DB. OD plus DB equal to OD plus DB equal to AC. Here DB equal to AC using 1. Let this is number 4 from triangle OAD. This is perpendicular. OD by OA equal to cos theta. Implies that OD equal to OA cos theta and OA equal to x cos theta. This is number 5 from triangle APC. Here we need AC. This is perpendicular. AC by AP equal to sin theta. Implies that AC equal to AP sin theta and AP is y sin theta. This is number 6. Since OB equal to x prime, therefore using 5 and 6 in 4 we get here OB equal to x prime equal to here OD equal to x cos theta and AC equal to y sin theta. This is number 7. Now here PB equal to PC minus BC. PC minus BC equal to AD. BC equal to AD using 2. This is number 8 from triangle This is APC. PC by AP equal to cos theta, implies that PC equal to AP cos theta and AP is y cos theta. This is number 9. Now we need AD in triangle OAD. AD by OA equal to sin theta, implies that AD equal to OA sin theta and OA is x sin theta. This is number 10. Since PB equal to y prime, therefore using 9 and 10 in 8 we get left side is PB is y prime, here PC is y cos theta minus AD is x sin theta. This is equal to minus x sin theta plus y cos theta. This is number 11. Writing 7 and 11 we get x prime equal to x cos theta plus y sin theta, y prime equal to minus x sin theta plus y cos theta, imply that in matrix form x prime y prime column matrix, here cos theta sin theta minus sin theta cos theta, this is coefficient matrix, here x y column matrix. Let we write these as 12 and this is 13. Let the column matrix x prime y prime equal to capital X prime, column matrix xy equal to capital X, and matrix cos theta sin theta minus sin theta cos theta square matrix equal to A. Then equation 13 may be written as capital X prime equal to AX. This is number 14. From 12 we see that we have found the variables x prime y prime as a linear combination of variables x and y. That means that is the set of variables x, y have been transferred linearly in the form of another set of variables. X prime and y prime, that is linearly transferred. And its matrix form is obtained in 14 equations of 12 may also be written as here x prime equal to, let this value is a1 x plus b1 y, and y prime equal to a2 x plus b2 y, implies that x prime y prime in the matrix form, here matrix form a1 b1 a2 b2, here xy, we may also write this as x prime equal to ax. Let these equations be 15 and this is 16. Similar to 15, let x1 prime equal to a11 x1 plus a12 x2 plus dot 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 a1n xn, x2 prime equal to a21 x1 plus a22 x2 plus dot 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 plus a2n xn dot 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 xn prime equal to an1 x1 plus an2 x2 plus dot 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 ann xn. Then column matrix x1 prime x2 prime dot 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 xn prime equal to coefficient matrix a11 a12 dot 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 a1n a21 a22 dot 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 a2n dot 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 an1 an2 dot 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 ann. Column matrix x1 x2 dot 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 xn. Let capital Y equal to column matrix x1 prime x2 prime dot 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 xn prime. and capital X equal to column matrix x1 x2 dot 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 xn, and A equal to A11 A12 dot 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 A1n A21 A22 dot 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 A2n dot 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 AN1 AN2 dot 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 ANN. Let this is number 17. Then 17 may be written as capital Y equal to A capital X. Let this is number 18. Similar to 18, let y1 equal to ax1 and y2 equal to ax2. Let alpha beta belongs to field then alpha y1 plus beta y2 equal to alpha ax1 plus beta ax2. This is equal to A alpha x1 plus A beta x2. This is equal to A alpha x1 plus beta x2. That is A alpha x1 plus beta x2 equal to alpha y1 plus beta y2. This is equal to alpha y1 is ax1 plus beta y2 equal to ax2. This is similar to T alpha x1 plus beta x2 equal to alpha T x1 plus beta T x2. This is 19 and this is 20. Comparing 19 and 20, we see that square matrix A plays same role as T. Therefore, A represents the function for linear transformation. A is called the matrix of linear transformation. And determinant A is called modulus of linear transformation. If determinant of A not equal to 0, then the linear transformation is said to be non-singular. And if determinant A equal to 0, then it is said to be singular. I hope that you are clear about the concept of linear transformation. Generally, in basic definition of linear transformation, we use the mapping T, but here we use the square matrix A in place of mapping T. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.